Good morning, afternoon, everyone. My name is Krant Kumar Appari, and I am presenting joint work with my colleague Prachi Ravichandra from Wipro Technologies. Today, I want to talk about how we write Claude code, a Anthropic's agentic AI coding engine, into Robo framework to create a single intelligent test automation framework that covers Android mobile apps, REST APIs, and web browsers all in one architecture. The problem we are resolving is one most QA teams will recognize. Writing and maintaining large test suites across multiple platforms is expensive and slow. We wanted to see whether a large language model could take a meaningful chunk of that work of engineers' plate and quantify the improvement. So let's get into it. The challenge. The backdrop to this work is a problem that gets worse as software system grow. Organizations are deploying across Android, microservices, APIs, and rich web frontends simultaneously. Each domain has its own toolchain, Appium for Android, HTTP client for APIs, Playwright, or Selenium for browsers. Keeping three parallel test suites consistent is a significant engineering overhead. On top of that, mobile UI tests are famously brittle. A small layout change can silently break dozens of locator based test steps, and the team only finds out when the pipeline goes red. And manual test authoring simply does not scale when you have 112 API endpoints or 47 application screens to cover. Writing individual test cases by hand takes weeks, not days. What we need was intelligence in the loop, a way to generate tests from requirements, heal broken locators automatically, and keep coverage high without proportionally increasing human effort. System architecture. Here is the four-layer architecture we built. This is figure 1 from the paper. Layer 1 is the requirement ingestion layer. Inputs enter as user stories or OpenAPI Swagger specification files pre-processed and fed into Claude Code's context window. Layer 2 is the AI generation layer, the heart of the framework. Claude Code produces Robo Framework test suite files, reusable keyword resources, and variable files using chain of thought prompting. This layer also hosts the self-healing locator module covered on the next slide. Layer 3. It handles the multi-platform execution. APM library for Android, request library for REST API calls, and the Playwright browser library for web testing, all sharing the same execution context, session state, and auth tokens. Layer 4 aggregates results into unified HTML reports, CI/CD pipelines, and thread dashboards. Self-healing locator workflow. This is figure 2 from the paper. The self-healing locator mechanism is in detail. The workflow starts on the left. Robo framework executes a test step and hits the locator check. If the element is found, the test passes and continues. The green S path. When the element is not found, the red no path. Rather than failing the run, the module captures a screenshot, accessibility tree, and DOM snapshot and sends them to Claude Code. Claude Code suggests a replacement locator. The apply locator node patches the test at runtime and retries. Success is logged as heal event. If it is still fails, the dash at retry loop continues. In our evaluation, this resolved 73% of Android UI locator failures automatically, and further 18% with single developer interaction, 91% of what would otherwise have been manual maintenance. Implementation highlights. Let me walk through that what was actually built in each testing domain. For Android, Claude Code analyzes the application's APK or UI automator output to understand the element hierarchy. then generates complete APM library test cases using W3C WebDriver keywords. When the self-healing module detects a locator failure, it captures the accessibility tree and screenshot, sends those to Claude code, and receives a replacement locator, all without stopping the test run. We also configured parallel execution through Pabot, which cut overall seat runtime by 43%. For API testing, the framework ingests OpenAPI 3.0, 3.x specification files and generates a dual test set. Positive test cases that exercise the happy path, and boundary and negative test cases that probe error handling, required field validation, and unauthorized access. Support for basic auth, bearer tokens, and OAuth 2.0 is included out of the box. For browser testing, we use the Robo Framework browser library, the official Playwright binding which supports Chromium, Firefox, and WebKit in a single suite. Claude Code enforces a page object model structure in the generated scripts, making them maintainable. The framework is also runs visual regression comparisons and Xcore accessibility audits at key page transition. Experiment results. Now let's look at the numbers. We evaluated the framework against real world application stack. A 47 screen Android e-commerce app, a RESTful backend with 112 endpoints across 8 resource domains and 23 page React web storefront, 3 experienced Robo framework engineers, each with 3 to 7 years of practice, ran a controlled comparison between the manual approach and the AI assisted approach. The headline results shown here as the gold callouts. The AI assisted framework generated 312 test cases compared to 148 manually. That's 111% more tests for the same engineering input. Authoring time dropped from 96 hours to 34. That means a 65% reduction. Looking at the quality dimensions in the chart, statement coverage improved from 67% to 89%. A 22% is point pain gain. API endpoint coverage rose from 73% to 94%. Defect detection yield increased by 87%. Maintenance events per month fell from 18 to 6, a 67% reduction, which the team attributed largely to the self-healing locator module, which automatically resolved 73% of Android UI locator failures and assisted with a further 18% in a single developer interaction. I want to be transparent about the study scope. This was a controlled evaluation with 3 engineers on one application stack. We discussed this as a threat to validity in the paper, and future work will extend to additional domains and teams. Contributions and future work. We have demonstrated a complete end-to-end framework that connects Claude codes, natural language understanding to Robo frameworks, keywords-driven execution. The contributions are a unified architecture spanning 3 platforms in a single code base, an AI generation pipeline that writes tests from specifications, a self-healing locator module that keeps CI pipelines green despite UI churn, and a quantitative benchmark validating the gains. For future work, we plan up four directions: extending coverage to iOS via XCUI test using retrieval augmented generation to feed domain specific context to the model for specialized applications. Adaptively improving the AS test generation heuristics from historical defect and maintenance data, and releasing the framework under the open source license to the community can validate it across the broader domains. The big takeaway is straightforward. When you combine a capable LLM with structured, library-rich test framework like Robo framework, you get a multiplier on both test volume and test quality without proportionally increasing the engineering effort. Let me show you my test bed. This is my test bed. We are maintaining instructions.md file which instructs the LLM to follow the steps. And here you can see this is my Claude model we are using. Then we pass the instructions here so that LLM fetches the test cases and convert the test case into Robo framework code. Thank you for listening us. I am delighted to answer any questions about the methodology, the experimental step, or the practical aspects of integrating Claude code into Robo framework pipelines. Thank you so much for your time to listening this.